Hello and welcome. So in this video we are going to talk about factory pattern. Factory is a part of creational pattern. Like everyone will be knowing, we have three types of design patterns: creational, structural, and behavioral. So factory is part of creational. Creational patterns are mainly they deal with object creation. So whatever related to object creation, how the objects are created, when and how many are created, like singleton. And so factory is also part of one of those, and then we'll see how the objects are created in the factory. So let's try to understand the factory with an example. uh, so let's say that we are creating a logging application. The logging application will have two types of things, like it can log in text file or it can log in Excel file. Okay, so at a time we will be using either text file or Excel file. Okay, suppose one of our application uses log in text file, maybe another we are using Excel file, but at time we are going to use one functionality at a time. So we need one object at for one particular process, right? So we have number of objects, right? We can have text file, Excel file, we can even have login DB, but at that time we are going to use only one object, right? So that time we need only one object, so factory will give us that object and we just use the functionality. So that's where factory comes into picture, where we have many objects of similar type, same type, we need one. Okay, and then we can use another in another place or right after that. So let's try to jump to Visual Studio and start coding based on this requirement, based on this logging requirement. My Visual Studio is ready. So in Visual Studio, I'm creating a new project, a new console application. I will name it as a Logger Factory based on our requirement. So let's create. Okay, so our program class is there with main class, and let's start coding what requirement we have. Correct. So I'll be just adding a class which would say logger class. Okay, so now let's remember the requirement. What is our requirement? Is like logging in text file and Excel file. Right. So let's, like, we don't know the factory design pattern, we don't know any design pattern. Let's just start developing to match our requirement, right? So let's have a function log. Okay, let this function take an argument what we want to log. Correct. Now let's see if we want to log in text file. Okay, so here the actual code of logging in text file goes. Sorry. Yeah, so I'll just write a sample. In real scenario, actual code goes here, right? So but I'm not writing, there'll be so many lines of code here, so this is for an example to understand. I'm not writing the code, just for understanding. And let's say we have one more log type we want to use is Excel. Excel. Okay, I will just say like this. So like if you see the overall requirement, we have our basic code ready. We have to just use that code here. Suppose this main method we are using as a, this is our client, is a client app. So what we do in client, we will create an object of log, new logger, and we will call that log function. Okay, what we want to log, let's say we want to use text. Correct. So our basic requirement is ready. Let's just build and say it's working fine, building fine. Okay. Yep, it's building fine. So we know it. Yeah, output is coming as a text log. So up to this we are fine. We have created based on our requirement, our code is ready. What is the problem with this code? Okay, and how factory pattern will solve our problems, right? Like every design pattern solves some problem, right? So we will understand what factory will solve the problem. First of all, for that, to understand what is the problem here, right? We have a logger class, we have function. If you see, this is doing multiple things. Okay, it's logging multiple things, like it is logging for text, it is logging for Excel. Tomorrow if we are adding any other logging, it is doing same thing. Okay, so what happens every time we are keep on adding, so everything this class is doing multiple things, so we are not following SRP here of solid principles, like single responsibility principles. It says like one entity, one class or one function should do only one things. Okay, we are doing multiple things here. Okay, at the long time it will be difficult to maintain, there will be so many lines of code here. Okay, another thing, if you see, suppose we have a new requirement to log in DB. So what we'll do, we'll come to this class, we'll come to this function, we'll add one more if condition, will add all the DB whatever logging functionality within here. So every time if any new requirement comes, we are coming to this class, we are changing this class, adding so many lines of code here. So one more thing what we are not following is open close principle, right? So what open close principle says, like our class should be open for extension but closed for modification. Correct. So what we are doing is we are doing all the modifications here. Every time new requirement comes, we are coming here and doing the changes. So we are not following that. Correct. It should not be like this as part, but still, like if you guys still not aware of solid principles, you can read that, and still if you know like not seeing so much problem, I can tell you like one more thing. Suppose we have a requirement, new requirement coming is login DB and login email. Send an email, right? We have this requirement, we have two developers, correct? So each one will work in one requirement, one will work in DB, one will work in email functionality. What happens, there is only one class, logger class, and there are two developers, so they have to work and then last they have to merge the code, correct? Or so what, there will be a problem, same class they have to work. Another thing is like you might think, okay, let's have how develop one developer create a new class and function and later we call here. Yeah, that is the direction, somewhat we are going in better direction. So but the problem with this class is, I say, parallel development. we are not able to do the parallel development. Okay, it is creates. So let's now start creating this as a factory and let's see if it solves the problems what we have. Correct. So before we create the factory, I would like to say what is the first step of factory is abstraction. So we have to first use either interface or abstract class. Okay, I'll be using interface, but you can, I mean, it can be an abstract class also can be used. There is no opposed to that. Based on your requirement, you can use, but I think interface suffices for this. So let me create an interface. This is our first step of factory. Let me add new item, call it interface, and I would say iLogger. Correct. This interface will have right now one functionality. It can have many functionalities, but right now what we want is log functionality. No parameters, no return, nothing. We are just doing log to understand as a simple. So our first step towards factory is done. What is the second step? Second step is creating subclasses which uses the app interface, right? So suppose what we are doing is we will create a subclass for this interface for each functionality. So one functionality we want is for text logging. So let's create a class. We call it as a text logger class. Just adding it. Now this class is type of iLogger, right? It has the logging function. So if it is type of iLogger means it will have functionality to log which should be implemented. So everyone on the same page. Now what we are doing is we are taking this functionality out of here and we have it there separately. We have it a separate class for that functionality. Similar way we can have a class for Excel. So I am creating Excel logger. Sorry, typing mistake. Okay, again this is iLogger type of class and it will have log functionality. So this one also we are moving out of here from here. Correct. So we have subclasses ready. Our second step is ready. I'm sorry, we have interface, we have subclasses ready. Now we have to go to third step. See, we are moving all the functionality out of here. We don't need it here. Okay, suppose what happens, like you will have a 100 line of code here. Okay, else if again 100 line, and suppose if you are adding one more thing, one more else if with 100 line, and tomorrow in case you are adding one more function which is log exception, right? And you pass exception or maybe whatever. Correct. What will happen? Again you will have if else and everything you will be here in one class. So at later point of time it will be difficult to maintain. Correct. So maintainability is the problem. So we don't need this here now. We have everything in a separate class. Correct. So what our third step is before I remove that is create a factory method. So we create a factory function that will be like here. Instead of this we will be creating a I will just use return type void, later we'll change. Let's say I am naming as get log. You can also name like log factory, no matter what you want. And here we can say what type of log we want, right? What actually this will do is we'll have a switch up this, and let's say we want log for text, correct? So this will return an object of text logger. Okay, here we are. Our factory pattern, what it do, it gives us the object which we want. So we are returning an object of Excel logger. Support, I'm just keeping a default. We are not doing anything for default, so we just say not implement, because we won't give any object. So which object they want, that only we'll give, otherwise we are not going to give anything. So let's remove this now. Here instead of this we have our factory method. This is our factory method. Okay, and now what it is returning? Text logger, Excel logger. What is this? All these are type of iLogger. So we are getting the iLogger type object whichever we want. So our factory design is ready by this time. Okay, so we have interface, subclasses and factory method. Let's see how we are going to use this in client. In client, now we don't need this new object. Okay, what I am going to do is we can make this as a static function, correct? You can even use as a normal function, then you need the object and use that. Okay, normally like whenever we use static, it is also called as a static factory, correct? So it's fine. I mean, so what we are going to get here is iLogger type of object, and our factory method getLog will provide us the object whatever we want. I will just put text here, and what happens, we have to just check what is the log method of the interface. We don't have to worry about each object inside that what it is doing. We'll just get the object, we use it. Now here the input can come dynamically, it can come through arguments, or it can come through configuration, or any other way. Okay, any other way. Okay, and based on that we will get that object which does us the functionality what we want. So this is our client code. If you see client code, we are not worried about how the object is created. Okay, tomorrow any new things, any new changes here, suppose text logger, we are changing the constructor like we will do this. Client doesn't have to worry. Client will be independent of object creation, right? So it just says get log, we just give them object, and here we can do any changes anytime we want, correct? So our client is just dependent on that interface type and that factory method, which will give us the output, and it does just have to use that. Okay, now let's see what problem we had. Did we solve all this problem using this factory method? First is SRP. So if you see now, each functionality is moved separately into their own class, so each has single responsibility. This is just logging text, this is just logging Excel. Okay, so we are not, everything is not done here. Okay, everything is separated, correct? Second is open close principle. Suppose we have a new requirement in DB. Okay, what we are going to do, we are going to add a new class. We will add a new class and implement that method. That's it. So all the lines of code like DB, logging DB has 20 lines of code. We don't have to add it here. It will be a separately. We are just creating an extension, not modifying. Only change would be here is 2 line of code. So easy to maintain here. Correct. So this is also solved using factory. Now our third problem was parallel development. Suppose there are two requirements coming together, login DB and email. There are two developers. Each can create their own class and work there, create the requirement. We don't have to worry. We don't have to keep on merging the code. Okay. Only will be like here we will have new additional functionality. So it will be quite easy to maintain. So all these problems were solved. Okay, so using our factory now we understand what factory is. Like we have an interface, we have subclass, we have a factory method which gives us this any of this subclass which is type of iLogger object, and we are using it on the client side. So I think now if we go and check what is the definition of factory design pattern, what is the UML diagram, we will be able to understand it. So let's just jump onto the definition. Definition I have taken from online. The source is dofactory.com. I have mentioned it there. So let's start. Like it says define an interface for creating an object. So we have an interface called iLogger, but let subclasses decide which class to instantiate. So we have the subclasses like text logger, Excel logger, okay. And the last line says factory method lets a class differ instantiation out to subclasses. So we have a factory method called getLog, which gives us the instance of like text or Excel log, anything whichever we want. So factory method lets class differ instantiation. We have a get log. We could have a get logger. Actually it gives us a logger kind of, but naming convention it's fine. So definition is clear. I think let's go to UML. If you see right side interface I product, then there are two classes, product A, product B. So same way we have I logger, we have a text logger, we have Excel logger classes. So I think that part, right side part is clear. If you go to creator, we have, it says factory method which gives us product. So we had an get log factory method which was returning us the logger. Now if you see client, what client was using, client was using that iLogger type of object which it was getting from factory method. So if you say product is equal to creator.factory method, so we had like logger.getLog, it was giving us logger type, iLogger type of object. So client I think clear. So I think UML should be easy to understand. This one also taken from online, the source is mentioned there. So once I think the code was clear, this too will be quite clear. Definition should be clear and UML should be clear. It is very easy to understand and you can use this factory method in different scenarios, so many scenarios in your day-to-day life. uh, so hope you don't have any question. Like you can go to do factory and check this definition there, and then once you create any class you can go to. So let's move to benefits. What are the problems solved? So we have already discussed. I'm just like briefing up again. Like we were following like SRP is followed, open close principle is followed from solid. Like this means like we are able, our code is easily maintainable, we are able to reuse. So first benefit is clear. Second is it allows parallel development. Yeah, that is also we have discussed. And it is allows being agile. That means like if we are releasing every week every new functionality, we can keep on adding classes and we can release it. So every week we can have a new release, and that's how agile goes. So it is easy, we can follow the agile without changing our code structure, and it will be easy. Last part is less dependency. So our client is not dependent on how we are creating the object, right? So any future changes in our library will not affect client. So it is quite independent. So that's why as client is not not dependent, it will be like very good idea. Like they don't have to keep on changing. So all these three benefits is solved by the factory, and I hope you understood the benefits very well, and you will apply this design pattern in so many areas. I'm just keeping it so that you can read it properly till you understand all 3 points. Thank you.